Hi, in today's lesson I'm going to very briefly go over making a prime number function in the Lua scripting language. How do you determine if a number is a prime number? Well, it's pretty simple. It only divides into two things, 1 and itself. It must be divisible by those two things. This is why 1 is not a prime number, because it is only divisible by one number, which is 1, and 2 is a prime number, because 2 can be divided by 1 and itself. We're going to make a function that determines if a number is a prime number or not. It's going to take one input, which is the number we want to test. It's going to do a variety of conditions and calculations that tests whether this number is prime, and it's going to output either true or false depending on if that number is prime. So in Lua, we start our function definition by saying function. We're going to call it isPrime, and we want to pass in a number. We're going to call it x. The first thing we're going to check is if our number is less than or equal to 1, because if it's less than or equal to 1, then it cannot be prime. So we're going to say if x is less than or equal to 1, then we need to return false. And then we're going to end the statement. The next thing we need to do is we need to test if our number is 2, because if it is 2, then we automatically know that the number is prime. So we can do the same thing. We can say if x is equal to 2, then return true, and then we end the condition by saying end. Of course, if our number is not less than 1 or equal to 1 or equal to 2, there are other things that we need to check. How do we determine if a number is prime or not? Well, we need to check if any number other than itself and 1 divides into that number. For example, the number 50 is not prime because the number 25 divides into 50, because it doesn't have a remainder. Now in Lua and many other programming languages, you can use something called the Modulus Operator, which is the percent sign, and this will give us the result of the remainder. So for example, 50 divided by 25 is 2, remainder 0. So doing 50 mod 25 would actually equal 0, because it returns the remainder. If something has a remainder of 0, that means that number goes into the first number, so it must not be a prime number. We know that if all of the numbers before our input do not return a remainder of 0, that means that the number must be prime, because it only goes into 1 and itself. But we don't need to test for itself, and we don't need to test for 1, because that will always return true. My approach to this function would be, we're going to test every single number less than that particular value. Say for example our input is 7. We start off by testing 7 divided by 6, which would give a remainder that is non-zero. Okay, so then we test again. What about 7 divided by 5? What about 7 divided by 4? What about 7 divided by 3? Eventually we get to 7 divided by 2, and if that doesn't return a remainder of 0, then we know that our number must be prime. So this is going to happen iteratively, so we need to use something called a while loop. So in order to start this, we need to create a variable called y, and it's going to be equal to our input number minus 1. So for example, we're going to start off, if we want to start off dividing 7 by 6, we obviously take 7 and subtract it from 1, so we have our 6, okay? And we set that into a variable so we can reuse it later. We're going to now check if y is greater than 1. We're going to say while y is greater than 1, then we're going to perform this particular operation. Now we can use the modulus operator. We can say if x, our input value, modulus y, or modulo y, is equal to 0, if that is true, that means our number is not prime. So we can say return false, because our number is not prime, and then we end the statement using end. If this condition isn't met, however, and our remainder is non-zero, that means our number could still potentially be prime, so we need to carry on the iteration. So we say y is equal to y minus 1, so we can carry on. We then end the while statement, and then if we get to this part of the program, we've basically tested every single number less than our input, and none of them divide into our input. So that means we've reached 1, and that must mean that our number is a prime number, so we can return true, and then we can end our function by saying end. What we have here is now a function that takes an input, any number, and returns true or false, depending on if it is a prime number or not. I made a mistake in the code earlier. The while loop should actually use a do statement rather than a then statement. But now, essentially, we have a function that does what we need it to do. So, the way we can test this function is we can say print and then we use the name of the function, which in this case is prime. The first thing we should test is if any number less than 1 outputs true or false. It should output false, and as you can see, it outputs false, so we know this is right. If we type in is prime 1, then this should output false. If we type in is prime 2, this should output true, because we know that 2 is a prime number, and it does, so we know that this works. Now if we test other numbers, say for example I test 7, 7 returns true because it is a prime number. Say I test 25, 25 returns false because 25 is not a prime number. If I test 27, we know that 27 is not a prime number. You can also use this to test much bigger numbers if you need to see if they're prime. Say for example 1567, and we can see that it is a prime number. So we can see that our function works as intended. It's a very small function and it's very easy to read, which is what function should be. But we have a slight problem. If I type in the word Tyler, for example, a string value, and I click run, you're going to see that Lua crashes. It outputs an error because we're trying to compare a string value with a number, which doesn't make any sense. Also, if I type in a number but it's wrapped as a string, and I try and run this, again we're going to get the same error, which doesn't make a lot of sense because this is a number and we should be able to just ignore the fact that it's a string and still be able to check whether it's a prime number or not. So how can we get past this? The way I would suggest to do this is we first attempt to convert our number into, well, a number essentially, by using Lua's toNumber function. What this will do is this will attempt to convert our input into a number. If it is possible, then it will become a number, but if not, then it will become a nil value, right? So what this means is, now I'm going to print x to show you what I mean. If I type in the input and then I say what is the input of this particular value, and I run this, you can see that our input is 56. So this works for the number 56. But if I type in a string and I run this, you can see that because we've tried to convert a word into a number, Lua actually converts it into a nil value, which means this doesn't make any sense. So knowing this, what we can do is we can test if our value is nil, and if it is, we can just return nil because we don't want to interact with nil values. We only want to interact with number values. So we can say if x is equal to nil, then return nil. If we go ahead and run this now with our string, you can see that it returns nil. And if I attempt to run this with a number that is treated as a string, like this, and I click run, you can see that it outputs false because 57 is not a prime number, but the fact is it still works because we have encapsulated this into a string, but because we've converted this into a number successfully and tested whether it was a string originally or not, you can see that this works, which means our function is not only a lot more robust because it's not going to crash as often, but now it's also a lot more flexible because we can still use numbers. Now the only thing to talk about with this particular program is the issue of using larger numbers. Obviously this is great if we test it with small numbers, even numbers with 3 digits, this is fine. But if we get to numbers with, say, several digits like this is going to take a lot longer to run. And in fact, if we use really big numbers, Lua just refuses to process it at all because it's just too big. The problem here is that the function is scaling linearly, which means as the numbers get bigger, the program also takes longer by the same amount of time. This is a problem. It's not very easy to circumnavigate. It's possible that this function could be written recursively. That wouldn't fix the linear problem, but it would be another way of solving the problem that may also benefit the function in some way. For example, it would be easier to read and it would also use more memory rather than causing lots of iterations, which could be a benefit, but it depends on what it is you're trying to do. For now, this function is everything that it needs to be. It takes an input, it tests if that input is a number or not, and if it's not, then it will try to convert it into a string to prevent the program from crashing. It's easy to read. It does what it needs to do, it returns true or false, so it can be used in any of our programs, and this is ultimately the main concept of a function. I hope this lesson was useful for everybody, and until next time.